Greeting Factorians, here's the killer for tutorial about cars and conveyor belts for Factorio. This tutorial is here to share all I have gathered about cars and conveyor belts, advice I've received from Allaizn and the technical Factorio community, as well as my own findings. This tutorial is made for people who launch a few rockets and that are okay with the basics about Factorio. Cars and conveyor belts works without any mods. I used cars and belts because I was looking for a way to increase belt throughput, so I came to use this concept that is between conveyor belts and trains. A car has 18 inventory slots as they can have different filters, meaning that one car loop has a huge throughput, like my bus lane in my last megafactory that is able to carry growth of 62 blue belts of different products, and this is not the limit yet. Like belt splitters or railroad crossings, we can reroute or split cars and remerge line after. And in my opinion, using this method leads to results that are most of the time satisfying to watch 4K. Let's start off with a short introduction to the concept of UPS optimization. UPS is update per second, and optimizing for greater UPS means creating design that minimizes the usage of computer resources like CPU time and memory access in order to generate a particular level of production. Using benchmarks, we compare different builds in order to find which ones are capable of the fastest compute speeds, with the fastest build being the one that are the most UPS efficient. Being an objective criterion, some people consider this to be the true end goal in Factorio. But let's not forget subjective criteria such as beauty or design. During this tutorial, I'll refer to UPS efficiency by the words updates. First, let's talk about the car as container. A classic chest can only be reached in a little square, while a car has a much larger selection box that is at least a square with sides of 2 tiles. The tank is even larger, but the main focus will be on cars. You can press E4 to display that selection box. It is also by using this window that we'll be able to display active state to analyze inserters, collision box for cars and buildings, advanced tiles, or any option helping us create our factory. If that selection box has a small part in a game tile, the inventory is available for an inserter. It means we can have until a square with sides of 3 tiles available for inserters. This way we can connect 2 distant assembling machines or an assembling machine with a train in some cases. About updates, for now it seems that a car on the ground with no driver is still counted as an active entity. However, a game mate made a mod that sets car in inactive states if it's required for some benchmark tests. Unless it's necessary, I try to not use a large number of cars linked with too many inserters without a logic signal or very high throughput keeping inserters active anyway. Unlike chests, cars can have filtered slots in their inventories, but it is impossible to connect them directly to the circuit networks to read their contents. Game-changing mods such as inventory sensor are available if you need to be able to read the inventory contents. Now, let's have a few words about inserters. When an inserter is placed in front of something recognized as container, the inserter will save and lock that container. It can be a tile of belt, a beacon, a chest, and a car or a tank only if they hold their positions. We can use that. In a tight build, put the car first so inserters lock it, then build back the beacon allows to use more inserters for the throughput than a classic chest chain if you really need it. But this also means we can't put inserters right next to a belt in the car on belt system, as then the inserters will lock onto the belt as a pickup target rather than the cars. This means to pull from cars, it works best to pull from an empty tile next to a belt. When a car moves into that space, it will become the target for the inserters. We need to be careful about that because an inserter will remain active too much time without a good logic synchronization, and too many inserters unable to finish their task or without input container during activation consume a lot of processing time, decreasing UPS efficiency. And finally, how to use cars and conveyor belts. First, I'll show the way Allaizn told me as the best for updates, then I'll show you one other way that I like to use. Like I said before, a car selection box is slightly bigger than a 1x2 rectangle, such as its collision box. And collision seems to be calculating depending which advanced tile the car collision box is in. For that reason, it seems better to use car on the side of a belt to use less advanced tile with one car. We can identify easily which side to use by placing down a railroad portion. Also, a benchmark test claims that it's slightly better for the computer to update cars in a position with 0 as orientation, meaning facing north, and I'll keep that in all my factories. To reduce collision calculations, we need to reduce the number of entities on the advanced tiles path that makes the car in the loop. So if we try to use this way of thinking, we can have builds that can look like that. To keep cars separated in collision calculation, it seems better to try to keep them such as, while they are moving, they'll never use the same advanced tile, meaning that cars should be at the maximum each 44 ticks on a blue belt. We should also try to not change inserters targets too often. The only way I have found to have 3 inserters on a car at a stop, it is if when the car reaches that stop, we activate the belt tile for a few ticks so the car moves forwards far enough for the selection box to cover 3 tiles. We also need to be careful on how cars on the side of the belt behave when the belt turns, as sometimes the behavior is unexpected. To conclude with view-based efficiency, I like the funny quote from Allaizn. The most optimal way to do something is by not doing it at all, meaning that we should try to produce things the easiest way possible without additional or optional steps. For example, if we use a bus for resources, we will need balancing, and balancing have a cost with updates. And so, we can see some megafactory using a lot of direct insertion to not dispose of a resource bus and having remarkable good results and benchmarks. This is supposed to be the best way to use cars and belts for updates. But I prefer to experiment with other methods that allow tricks that we can't do if we only use cars on one side of the belt. Indeed, you have probably seen my first video showing what we can do with a car in the middle of a belt passing through beacons and assembling machines. This concept was the first used by Allaizn and Anti-Elites, and I know of thanks to Kuber experiments in our megafactory. Allaizn was looking an optimized solution for updates, so he quickly gave up with that solution because the car used 4 advanced tiles and there is a lot of items on those tiles each time, meaning more calculations. I was searching for a funny looking compact megafactory, and somehow this way to produce fits my need. In order to center a car on a belt, with the first method we need at least one collision, generally with walls or pipes. Then, once the car is correctly centered, we can make the car pass through beacons and assembling machines. Without any other collisions, the car will usually keep the middle of the belt during turns as well. The second method by Allaizn shows how to center a car on a belt with no collision. It's long and a bit unusual. I have tried to optimize few things starting from the last blueprint Allaizn showed me with that way. To start some tests, he taught me that we can tag a car by placing an item under the car directly on the belt. And thanks to tools already in the game such as reading belt content, we can simulate the information on the car position. With Allaizn, we call that item tagging a car a toy, but it is finally just a testing tool. I don't recommend using that practice for a factory. To control the car flow, it is better to use the circuit network. It takes 11 ticks for a car to traverse a single tile of blue belt, and thanks to that, it is easy to make a clock and set up each car stop so they release each car and the pattern we need. You can see in my previous video and my save the setup I use for clocks and the result on each car stop and train stations. For each car pattern we are looking for, there is a way of making it work with the game tools. We will not forget to synchronize inserters with circuitry so they are in an inactive state while they are unable to reach a car. Thanks to Rengel, Allaizn and the Troller, a collision can also be a solution to make a very simple splitter for cars using basic circuits. We use items in the car inventories to identify a car. When an inserter grabs a filtered item, a gate then activates to force the car in the correct direction to have that item returned to the car's inventory. Allaizn cargo version can reroute a car every 60 tick maximum, so I made a version able to keep a higher throughput. With the same way of thinking, I made a car stacker. When a lane is used by a car, it reroutes the next cars to the next lanes. And finally, to switch items from a car to another one, I use this blueprint. It can be used for both car directions, but one of the directions requires shifting the car away from the center of the conveyor belt. I also want to note that the inserters are in the same advanced styles as those used by the car, meaning that they are not the best for updates, but they are the best for throughput so far. 6 stack filter inserters working from a container to another, meaning a throughput of 166 items per second. It's between 3 and 4 blue belts. I have shown in my previous videos a version to transfer items from a train to a car, and because I don't make from belt to car so far, I don't have any blueprint to share for that use case. As conclusion, there are 3 major ways to move a resource in the game: conveyor belts, bots, and trains. While the game is pretty well optimized to make use of those first 3 options, cars and belts seems to be a bit less UPS efficient than the other options. This may change in the future. Thanks to the amazing optimization work done by the Factorio developers, we are able to make megafactories with cars and belts. I've linked myself in the comments. This is a factory for 3000 science per minute. This factory has many flaws about repairs efficiency, like having a bus for a megafactory, and I don't use all Allaizn's advice in it. But I'm able to launch a rocket every 20 seconds at 60 FPS. We can see in the UPS word challenges from Technical Factorio that the smart use of conveyor belts and trains mostly wins. You will find the links in the comments, and I thank the player who made it for sharing such interesting results. However, we keep in mind that Factorio is a sandbox game when sometimes we want to achieve a goal with a different path for fun and challenge. To create cars and belts blueprints, it's better to use the editor and quality of life mods such as editor extension, blueprint flip and turn, bottleneck, assembly analyst, and maybe a few more of your own selection. I have left a few links in the comments about Allaizn's research into cars and belts, UPS word challenges from Technical Factorio Discord, benchmark tests, and related links about cars and belts I know with good findings in them. I hope you have enjoyed watching this tutorial and it was helpful for your factory. I tried to keep it simple and short, but if you feel you want me to cover something in more detail, please let me know. I wish to thank Allaizn, Night Elite, the Technical Factorio Discord, and the Factorio community. I also thank the developer for the game. Thanks for watching and take care.